Hello everyone, I am Parvati Angdi, Department of Electronic and Communication Engineering from Sri Venkateshwara College of Engineering in Bangalore. Today I am going to discuss about classification of electrical network. Introduction to electrical networks. Electrical networks are essential for the distribution of electrical energy. They consist of interconnected electrical components such as resistors, capacitors, and inductors. Understanding the classification of these networks helps in their analysis and design. Types of electrical networks. Electrical networks can be classified as linear or non-linear networks. Linear networks obey the principle of superposition, while non-linear networks do not. This classification affects how the networks respond to different signals and loads. Active versus passive networks. Active networks contain components that can supply power, such as batteries, amplifiers. Passive networks consist of components that only store or dissipate energy, like resistors and capacitors. The distinction impacts the network's ability to amplify signals and power levels. Two-port networks. Two-port networks are used to model the behavior of electrical circuit with two terminals. They simplify the analysis by representing the input and output characteristics. Common parameters for two-port networks include impedance, admittance, and transmission coefficients. Linear time invariant network. LTI network are characterized by linearity and time invariance properties. These networks can be analyzed using frequency domain techniques such as Laplace transforms. They exhibit predictable behavior to sinusoidal inputs, making them easier to model. Digital networks. Digital networks operate using discrete signals rather than continuous signals. They consist of components like logic gates, microcontrollers, and digital processors. This classification is crucial for modern communication systems and computing applications. AC versus DC networks. AC is nothing but alternating current networks. Involves electrical signals that vary over time. DC is nothing but direct current. Networks has constant voltage and current characteristics. The classification influences how power is generated, transmitted, and consumed. Series and parallel network. Series networks have components connected end to end, sharing the same current. Parallel networks have components connected across the same voltage or source, sharing the same voltage. The arrangement affects the overall resistance, current, and voltage in the network. Unilateral and bilateral networks. Unilateral networks allow current to flow in one direction only, like diodes. Bilateral networks permit current flow in both directions, such as resistors and capacitors. The type of networks determines the response to input signals and circuit behavior. Conclusion. The classification of electrical network is essential for effective analysis and application. Each type of network serves different purposes in electrical engineering and technology. Understanding these classification aids engineers is designing more efficient and functional systems. Thank you.